All right, listeners, buckle up. We're diving deep into some really fascinating malaria research today. And we're not just talking about mosquito bites and fevers, we're going way beyond that. We're exploring a totally new angle on how malaria messes with the brain. You see, the research we're looking at suggests that liver dysfunction, regardless of how bad the malaria infection is, could be a major player in the cognitive issues people face even after they've recovered. So instead of just looking at the parasite attacking the brain directly, we're going to be focusing on the liver's role in all of this. What if the liver is the missing piece of the puzzle when it comes to understanding the long-term effects of malaria?
That's a really intriguing question, and it's exactly what this research is getting at. It challenges our traditional understanding of how malaria affects the brain, and it could potentially lead to some really exciting new treatments and prevention strategies.
Okay, so before we get too deep into the specifics of this new research, can you give us a quick recap of the existing theories about brain damage and malaria, just to set the stage for our listeners?
Absolutely. So traditionally, there have been two main hypotheses, the sequestration hypothesis and the inflammatory hypothesis. The sequestration hypothesis basically says that parasite-infected red blood cells, they kind of clog up the brain's tiny blood vessels. And this leads to damage because the brain's not getting enough oxygen.
So like a microscopic traffic jam in the brain?
Precisely. And then you've got the inflammatory hypothesis, which is all about the body's immune response. It suggests that the immune system goes into overdrive fighting the infection. And this causes inflammation and swelling in the brain, which, can be pretty harmful.
So it's like your own body's defenses accidentally causing damage while trying to fight off the parasite. Okay, that makes sense. But the research we're talking about today kind of hints that there might be more to the story than just these two mechanisms.
You're absolutely right. While both of those hypotheses explain a lot of what we see, there are some cases where they just don't fully account for the cognitive issues that pop up after malaria.
Okay, so what are we talking about here? What are the things that don't quite add up?
Well, for instance, people who are recovering from cerebral malaria, where we know there are blockages in those brain blood vessels, they should theoretically have a ton of neurological problems, similar to what you might see after someone has a stroke.
That seems pretty logical.
But the interesting thing is, the data doesn't really back that up. The rates of long-term neurological problems in these people are actually lower than what you'd expect.
Yeah.
So it's kind of like a puzzle.
That is pretty interesting. What about the fact that the parasite can attach itself to blood vessels in other organs too? Doesn't that make things even more complicated?
Oh, absolutely. The parasite can actually latch onto blood vessels in organs like your heart or intestines, but it doesn't cause the same level of damage that it does in the brain. So clearly there's something else going on here, something more than just the parasite blocking up blood vessels.
Yeah, and here's another thing that's always kind of confused me. Cognitive problems can happen even after non-cerebral malaria. Sometimes even after infections that were basically silent.
Exactly. That really points to something else being involved in these cognitive problems. And that's where the liver enters the scene.
Okay, the liver. Tell me more about this connection. Why is the liver suddenly a suspect in all of this?
Well, this research suggests that even though the liver isn't the main target of the malaria parasite, it still takes a hit during the infection. You see, the parasite, especially this one called Plasmodium falciparum, it releases a ton of toxic byproducts as it replicates in your bloodstream.
So the liver, which is already busy filtering and detoxifying your blood, it gets bombarded with all this extra junk on top of its regular workload.
Precisely. And that puts a ton of stress on the liver, which can end up messing with its ability to function properly.
Meaning a damaged liver can't filter out those toxins effectively, which then
allows those toxins to build up in the blood. And eventually they make their way to the brain. One of the main culprits here is ammonia, which is a byproduct of protein breakdown.
So even if the parasite itself isn't attacking the brain directly, the toxins from a struggling liver might be causing the trouble.
That's a hypothesis. And what's really interesting is that there's actually a condition called hepatic encephalopathy, or HE for short. And it really supports this idea.
Hepatic encephalopathy, I'm not familiar with that one.
So in HE, liver failure leads to a buildup of toxins in the blood, just what we were talking about. And these toxins can seriously impair brain function. Even mild cases of HE can cause all sorts of cognitive issues, from confusion and memory problems to even personality changes.
Wow, and are you saying that these symptoms in HE are similar to what's seen in some malaria patients?
Yeah, there are some pretty striking similarities, which makes the argument that damage to the liver, not just the parasite itself, can be a major factor in the cognitive problems after malaria. It's not necessarily one or the other, probably a
Yeah.
combination of things.
It's amazing how one research paper can open up so many new ways of thinking about things. This whole liver connection really adds a new layer of complexity to our understanding of malaria, wouldn't you say?
Absolutely. It challenges us to reconsider some of our assumptions and explore alternative explanations for the long-term effects of this disease.
Now, I remember the paper mentioned something about MRI scans. What did those scans reveal?
Right, so the paper pointed out some interesting similarities between the brain scans of people with cerebral malaria, pediatric cerebral malaria, and hepatic encephalopathy.
So visually, the brain looks similar in all three
To a
cases.
certain extent, yeah. But there are some subtle differences in the scans, and researchers believe those differences are related to how long the liver damage has been going on and how severe it is in each condition.
Okay, that makes sense. Someone with chronic liver disease would probably have more expensive damage than someone whose liver was only affected during a malaria infection.
Exactly. The MRI findings really provide more evidence for the potential role of liver dysfunction in all of this.
This is all so incredibly interesting, but I have to ask, if this liver hypothesis is so compelling, why isn't it more widely accepted? There has to be some pushback or alternative viewpoints, right?
Oh, of course. In science, there are always different perspectives and healthy debate. That's what drives progress.
So, what are some of the main arguments against this liver hypothesis?
Well, one argument is that some studies suggest liver dysfunction isn't actually that common in malaria, especially in uncomplicated cases.
So, if it's not widespread, how could it explain cognitive issues in so many malarial patients?
Well, the researchers who support the liver hypothesis, they point out that even mild liver dysfunction, it can have a real impact on cognitive function. You don't need full-blown liver failure to cause problems.
Ah, I see. So, even small changes in liver function during a malaria infection could have long-term consequences, like a domino effect.
Precisely. And they also point out that the reported rates of liver damage in malaria, they vary quite a bit across different studies, which could be due to how liver damage is defined and diagnosed, or limitations to testing methods, or even differences in the groups of people being studied.
So maybe we're underestimating how much liver damage is actually happening in malaria because we're not always looking for it in the right way or with the right tools.
That's a valid point.
Yeah.
Another counterargument is about the different species of malaria parasites,
Yeah.
besides Plasmodium falciparum.
Right, like Knowlesi, oval, and malaria. If liver damage during malaria is really driving those cognitive issues, why don't we see the same problems after infections with those other species? They affect the liver too, don't they?
Yeah, that's a great question.
Mhm.
And there are a couple of possible explanations. First, it could just be that we haven't looked closely enough. Maybe cognitive problems do happen after infection with those other species, but we need more research to know for sure.
So more research is definitely needed in those areas.
Exactly. And second, there might be something unique about Plasmodium falciparum and vivax,
Mm.
the two species that are most strongly linked to cognitive problems, something beyond their effects on the liver. Maybe they produce a specific toxin that's particularly harmful to the brain, or maybe they trigger a different kind of immune response that's more likely to cause inflammation. Again, more research is needed to figure all of this out.
Right. So while this liver hypothesis is super interesting and potentially groundbreaking, there are still a lot of questions to answer and nuances to explore.
Absolutely. This new hypothesis doesn't necessarily mean the other ones are wrong. It's not an either-or situation. It's likely that multiple factors contribute to brain problems after malaria. And this research suggests that liver dysfunction might play a bigger role than we thought.
It's like we're adding another piece to the puzzle, and with each new piece, our understanding of malaria becomes more complete and more nuanced. This is all so fascinating, and I'm really excited to dig deeper into the implications of this research and what it could mean for how we treat malaria in the future. But first, let's take a quick break to gather our thoughts. We'll be back in a bit to continue our deep dive into the world of malaria and the liver.
Sounds good to me. What's really exciting about this whole liver connection is that it could completely change how we think about treating malaria.
Okay, I'm all ears. Tell me more.
So up until now, most anti-malarial drugs have been all about killing the parasite.
Yeah, which makes sense, right? You want to get rid of the infection.
Exactly. But this research suggests that maybe we should also be thinking about protecting the liver while we're at it.
So like a two-pronged approach. Target the parasite and shield the liver from damage at the same time.
Exactly. And the cool thing is there's already some promising research happening in that area. Scientists are looking at drugs that can reduce oxidative stress and inflammation in the liver. basically acting as like liver protectors.
Ah, so it's like giving the liver a little extra support to help it get through the malaria infection. I like that analogy.
Yeah, it's a good one. And the hope is that by preventing, or at least minimizing liver damage during malaria, we can lower the risk of those long-term cognitive problems down the road.
That could be huge. We're not just talking about treating the infection in the moment anymore. We're talking about preventing future complications. And when you think about the impact this could have, especially for kids in areas where malaria is a constant threat.
Absolutely. Children are so much more vulnerable to the long-term effects of malaria on the brain because their brains are still developing. Any damage during those critical years can have a huge impact on their cognitive abilities and their future potential.
Yeah, it's heartbreaking to think about all those kids who might be struggling with learning or developmental delays because of a disease that we know how to prevent.
It really is.
Mm.
And that's what makes this research so important. It gives us hope that we might actually be able to protect future generations from these devastating consequences.
I mean, if this liver hypothesis holds up, it could totally change how we think about and approach malaria treatment and prevention.
I agree. It could lead to incorporating liver-protecting strategies into our existing anti-malarial treatments.
And hopefully it'll mean better outcomes for so many people around the world, especially children.
That's the goal.
Mm-hmm.
Of course, we need more research to confirm these findings and figure out how to turn them into effective treatments. But it's definitely a very promising area to explore.
You know, all this talk about liver damage and its potential connection to cognitive problems makes me wonder why we don't see more obvious signs of liver problems in people with malaria.
That's a really good question. And it goes back to something we talked about earlier, the limitations of how we diagnose and detect liver damage.
You're saying our current methods might not be sensitive enough to catch those subtle changes in liver function?
Yeah, that's definitely possible. We rely a lot on blood tests to check liver health. But those tests aren't perfect. It's totally possible for someone to have liver damage that doesn't show up in their blood work, especially in the early stages when the damage is still pretty mild.
It's kind of scary to think that there could be this silent threat lurking under the surface.
It is. And it really highlights the need for better diagnostic tools for liver disease, especially in places where malaria is common.
Imagine if we had a simple, quick test that could accurately tell us how well the liver is working.
That would be amazing. It would allow doctors to identify people who are at risk of liver damage really early and start treatment before any serious complications develop.
And potentially prevent those long-term cognitive problems from ever happening.
Exactly. This is an area where advances in technology can make a huge difference in the fight against malaria. It's not just about new drugs anymore. It's also about better tools for diagnosis and monitoring.
It's incredible how this one research paper has sparked so many thought-provoking questions and potential new directions for research.
I know, right? It's a testament to the power of science and the importance of challenging our assumptions. We started by talking about the brain, then we moved to the liver, and now we're talking about diagnostics and the future of malaria treatment.
It's all connected. That's what makes science so fascinating.
Absolutely. It's like peeling back the layers of an onion. Each layer reveals new complexities and wonders.
I love that analogy.
Yeah.
It really captures the essence of scientific discovery. And even though there are still many unanswered questions, I feel like we've gained a much deeper understanding of malaria and the potential long-term effects it can have.
I agree. This has been a really insightful deep dive.
Yeah, I think we've covered a lot of ground today, and it's probably time to start wrapping things up for our listeners.
Sounds good to me.
So, as we wrap up our deep dive today, what are the key takeaways you want our listeners to walk away with?
I think the biggest one is we really need to broaden how we think about malaria. For decades, it's been all about getting rid of the parasite. And while that's obviously still super important, we can't forget about the long-term effects the infection can have, especially on the brain.
It's about looking at the whole picture, not just that initial fight against the parasite.
Exactly. And this new research, with the link between liver problems and those cognitive issues, it just adds a whole other layer of complexity.
It's like realizing the battle scars can stick around long after the war is over.
Yeah, I like that. It really emphasizes how we need a more well-rounded approach to how we treat and prevent malaria.
So what would that look like, practically speaking?
Well, first off, we got to invest more in research.
Yeah.
We need to really understand how malaria, the liver, and the brain are all connected.
We need to untangle that web and see how each part affects the others.
Precisely. And we need better tools for diagnosis, something that can catch liver damage early on, even if it's mild.
So we can step in before those small changes turn into something serious.
Exactly. And of course, we need to be looking for new treatments, treatments that not only kill the parasite, but also protect the liver from damage.
Shifting our focus from just dealing with the immediate crisis to thinking about long-term health.
Couldn't said it better myself.
The fight against malaria isn't over when the fever breaks. It's about making sure those who survive can truly thrive and live full, productive lives without the burden of long-term complications.
Absolutely. And that's where this new research gives us hope. It suggests that by protecting the liver, we might be able to prevent some of the worst effects of malaria.
This has been a truly eye-opening conversation, and I want to thank you for sharing your expertise with us.
It's been my pleasure.
And to our listeners, we hope this deep dive has given you a new way of thinking about malaria and shown you how important it is to look beyond the surface. Remember, there's always more to discover, and we encourage you to keep exploring the amazing world of science. Until next time, stay curious.